Hello, my dear student. Today our we will start our discussing new chapter, the chapter number 12, and the name of this chapter is Magnetic Effects of Current. Chapter 12, the name of our chapter is Magnetic Effects of Current. Here, our first word is magnet. What is magnet? I am discussing about magnet. What is magnet? The magnet is any material. The magnet is any material capable of attracting magnetic object and producing a magnetic field outside itself is called magnet. Okay, I am repeating again. What is magnet? Magnet is any material capable of attracting magnetic object and producing a magnetic field outside itself is called magnet. Okay, uh, magnet have two poles. You know that magnet have two poles. Magnet have two poles. One is north pole and another is south pole. We know that similar poles repel while the dissimilar poles attract each other. We know that the similar pole repel while the dissimilar pole attract each other. Okay, now by using magnet we can get current. By using magnet, by flowing current we get magnet. By flowing current we get magnet. This is called magnetic effect of current. This is called that magnetic effects of current. By flowing current we get magnet or magnetism. This phenomenon is called the magnetic effects of current. Okay. Okay. Now I am discussing how we get the magnetic field, and again I am saying that the magnet is a vector quantity. So it has a magnitude as well as direction. So it is our very important topics, and by flowing current in different direction we get the magnetic field in different direction. Okay, and this phenomenon is first invented by our scientist Weierstedt. Weierstedt first invented the magnetic effects of current. Okay, then now I am discussing the magnetic effects of current. Magnetic effects of current. What is magnetic effect of current? By flowing current we get a magnetic field around the conducting wire. This phenomenon is called magnetic fields of current, and this is invented by our scientist Bigyanik Weierstedt. Now, how we can get the direction of the magnet by using flaming right hand rule. By using flaming right hand rule, we can get the direction of magnet. And this is, you can see that this is the bigger flaming right hand rule. According to our thumbs, the current will flow, and by others fingers, by the direction of others fingers, we get the magnetic direction of magnet. Okay, according to our thumbs we get the direction of current, and according to the direction of other fingers we get the direction of magnet. Okay, now if this is a connecting wire and the current is passing through A to B, then what will be the direction of our magnet? Okay, we know that by flowing current around this conducting wire, we get a magnetic effect. But in a fixed point, on this point, what will be the direction of our magnet? We can determine this direction by using our Fleming's right hand rule. Okay, for this point we can see that, for this point, suppose this point is P. For this point we can see that we know that in our direction of current we place our thumb's finger, then in other finger, then by the direction of other fingers we get the direction of magnet. Okay, look at the board. By our direction of our current we place our thumbs, and according to the direction of others fingers we see that the direction of magnet on this point is towards the board, into the board. So we can denote as this as the magnetic direction of magnet on this point as a cross. If the direction is into the board, then we can denote the direction as a cross. Okay, again for this point, suppose this point is, the name of this point is Q, then we get the direction of magnetic field as place your try it at your copy, at your CW copy. We place our thumbs according to the direction of current. Then for this point, the direction of magnet is outside the direct of magnet is shows that the outside of the board. For outside of the board, we can denote this direction as a dot. So when we see the cross, then we can we know that the direction of magnetic field here is into the board, and as a notation of dot we can say that the direction of magnet is outside the board. Okay, okay. For another direction we can determine, for any direction we can determine this by using right hand rule, or Fleming's right hand rule. Okay. Now Now we are going to discuss Now we are going to discuss our most important topics on this chapter, and that is transformer. Transformer is the most important topics. All of the questions are set on this chapter from the topic, our most important topic, transformer. Now, what is transformer? Now our topics is transformer. What is transformer? Now our question is, what is transformer? An apparatus for reducing or increasing or increasing the voltage of an alternating current or AC current, in short, current is called transformer. Okay, an apparatus for reducing or increasing the voltage of an alternating current, in short AC current, is called transformer. Here we will use AC current. What is AC current? The current which this is a AC current. The current which always changes its direction in many points is called alternating current. In our DC current, we have two types of current. One is alternating current, and another is, this is AC current, and another is DC current, direct current. In direct current, we see that there is no changes of direction. Okay, so in a transformer, DC current is not used for these conditions. Okay. So we will use our alternating current, AC current. So this is the definition of transformer. We have two types of transformer. And there is two types of transformer. One is step up transformer. Another is step down transformer. Okay. In our step up transformer, we will get in a transformer we have two part. One is input and another is output. In our input part, we says that as a primary coil, and our output coil we say that is secondary coil. In input part, we that is known as input part is known as primary coil, and output part is known as secondary coil. Okay. In our step up transformer, in our output we get the higher voltage and less current. Okay, and in our step down transformer, we get, in our output we get the lower voltage and high current. Okay. Okay. Now our topic is step up transformer. Now our topic is step up transformer. What is called step up transformer? What is called step up transformer? Or what is step up transformer? It is a very important type of knowledge based question. Okay, what is called transformer, or what is called step up transformer, or what is called step down transformer? This, all of these are very important for knowledge based question. Okay. Okay, now the definition of step up transformer: the transformer which converts an an electric current of greater strength at low voltage into an electric current of weaker value at high voltage is known as step up transformer. Okay, I am repeating: the transformer which converts an electric current of electric current of greater strength at lower voltage into electric current of lower strength at high voltage is called step up transformer. By the definition of step up transformer, we get that in our input side the current is greater or strength, and in our output side the current will be weaker than input or primary coil. Okay, and again we get that the lower voltage is converts to high voltage. Okay, how 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 it converts? Okay, now I am because of it is a revision class, so I am discussing it in a short. Okay. So this is a step up transformer. In our step up transformer, here the number of turns of coil. Here the signal, this signal is called AC signal. AC signal as generated as this, and our output signal, the number of turns will be greater than the input, and this is our output voltage or EMF. And this side here we get the two part. This is the input part and this is the output part. Input, and this is the output part. This coil is called primary coil, and this part is called secondary coil, and these are the number of turns. Here the number of turns N is denoted as NP. This side is primary coil, so the number of turns is denoted as NP. The voltage is also denoted here as EP, and the current is also denoted for this part is IP. Okay. And for the secondary coil, the number of turns is denoted as NS, the current is denoted as Is and the EMF or voltage is denoted as Es. From this figure or from step of transformer we get that the number of turn is the number of turn for secondary coil is greater than the number of turn for primary coil. Okay, the number of turn is the number of turn for secondary coil ns is very much greater than the number of turn for our primary coil. Okay, okay, here the number of turn is very much greater, so in this part the resistance is very much higher than the input part or primary coil. So here, because of the increasing of the resistance for this part, the current will be less than the primary coil. Okay, because the current and resistance are inversely related. Okay, okay. For step-up transformer, we get the conditions as NS is greater than NP, and we also see that we also get IP is greater than IS. Okay, for step-up transformer. For step-up transformer, and we also get that EP. ES is greater than EP. According to our definition, the current of strength will be current will be or converts into weaker, and the number of turns, the voltage of of primary coil will be greater, will convert into higher. Okay, these are the parts for step of transformer. Now we can get the relations among these terms. The relations among these terms, we can write the relations here. The relations between EP and ES, NP and NS as EP, or we can write NP by NS equal to EP by ES. Okay, again we can write that the relation between number of turns and current is NS NP by NS equal to IS by IP. Okay, then we will get the another relations, and that is among voltage and current, and the relation between voltage and current is EP by ES equal to IS by IP. Okay, okay, these are the relation among these three terms for step of transformer. Okay, okay, and including these three relations, combining these three relations, we can write in short NP by NS equal to EP by ES equal to IS by IP. This. Okay, this is the discussion about a step of transformer. Now we will discuss about a step down transformer. Okay. I'm drawing the figure for a step down transformer. In step down transformer, the number of turns will be greater than the number of turns for primary coil will be greater than the secondary coil. Okay, here this is the number of turns NP. This is the input. Input part is known as primary coil. Okay, and that is IP, and here the voltage will produce and use as name as IP, and here number of turns is known as NS, IS, and ES. Here the conditions for a step down transformer is now I am discussing about the definition. What is the definition of step down transformer? The transformer which changes the high potential less electric current into low potential high electric current is called step down transformer. I am repeating, the transformer which changes the high potential less currents into less potential high current and high electric current is called a step down transformer. I am repeating again, the transformer which changes the high potential less electric current into low potential high electric current is known as step down transformer. Okay, and this is the input part, and input part is known as primary coil, and this is the output part is known as secondary coil. For the step down transformer, the conditions among these three terms is NP greater than NS. Okay. Next, the another condition. These conditions are very much important for MCQ question. Okay. And then according to the definition, we get that it changes high potential, low electric current. So in our input part, the electric current will be low, and the output current or for secondary coil, the output current IS will be high. So we can write IS is greater than IP according to our definition. Again, we see that here according to definition, we get that it changes high potential to lower potential, so the number of third condition, the third condition is EP greater than ES. Okay, these are the condition for a step down transformer. Okay, now I am writing the final equation for step up transformer and step down transformer is same. Okay, now I am writing the relations among these three terms as NP by NS equal to EP by ES equal to IS by IP. Okay. Okay. In this is uh, uh, in our next class we will solve a mathematical problem on these topics. Okay. Okay. So until then, thank you.